Hello, everyone, and welcome to the third episode of the Future is Robot podcast. Today, I'm joined by Antonio, and he is the team leader at PAL Robotics. I'm really glad to have him here for this particular episode. And he's also a teacher on Udemy, where he teaches about robotics and has courses in two different languages at that. And today's conversation is going to be about his role as both an engineer and an educator in the field of robotics, along with a discussion and exploration into his journey, starting right from his undergraduate studies till right now, and obviously his future plans and visions with respect to robotics, automation, and technology in general. So, hi, Antonio. Glad
Hi,
to have you.
Chandran. Thank you for having me. And also thank you for this podcast that you are bringing to the robotics community and also to the robotics students that are out there and that are passionate like us about robotics in general. And well, quickly about myself, thank you for the introduction. And I started my career back in 2018 now. It's a long time ago, actually. I started with an internship in Philip Morris International, and actually there I was not really working with robots. I was more working with data science projects, and then I moved to Bosch, in which I really started to work with robots, with autonomous mobile robots. That is then the field in which I continued my career also now in PAL Robotics, in which I'm working as an autonomous navigation engineer. And here I'm the team leader of the autonomous navigation engineer team. And we have we are working basically in the autonomous navigation team in mainly three different fields that are autonomous navigation, localization, and also perception. So this is behind our responsibilities.
I see. That's an extremely interesting, array of different responsibilities and actions as such. So just to give a quick introduction to all our listeners, could you just, briefly explain the terms of localization and perception when it comes to autonomous vehicles and automated vehicles as such?
Yeah, well, actually, these three problems that we are talking about, so navigation, localization, and perceptions, are very linked together, and they strictly depend one with the other. And actually, if you just look to the autonomous navigation problem, that is going from a point A to a point B, is just a very simple problem if you have all the information that you need. If, you, for example, you already know perfectly where you are and where you want to go, so the localization problem, then it's very easy to plan a path that brings you from the starting point to the end point. And as well, if you already know all the obstacles that you will encounter during your path, it's very easy to avoid them. And so actually, the most challenging ones are the perception problem and the localization problems. And well, there are very lots of different technologies that are involved in these fields, and many of them are very recently developed. So there are a lot of algorithms. I know that in one of your previous podcasts you were introducing about SLAM algorithms,
Mhm.
and there are very some SLAM algorithms about, for example, graph SLAM or like these that are very recent. And so, I mean, very recent in the words of robotics means 5 years, but anyway, when you have to bring these algorithms, this logic from the just papers, from the research to the real robotic project, it needs sometimes to improve them and to integrate them properly with a fleet of robots.
Mhm. So, as you mentioned, the most difficult aspect is with respect to either localization or with respect to perception. So, what are the main, factors that make these two elements so difficult in the field of robotics as such?
Well, I think that a huge limitation is the perception side, and so the sensors.
Mm.
Is a limitation both from the point of view of the sensor itself, that they are inevitable, introducing some errors and some noise and uncertainty in general. And also, this is a challenging problem from the point of view of the companies that are building the products, that they want to offer the best product, but then they also have to think about the price. So you cannot have a robot with a $10,000 sensor, and then you want to sell it for $300. So this is the example, for example, of iRobot, no, that they made the Roomba. They cannot sell a Roomba for $10,000. No one will can afford it, most probably. And so this is the real challenge that we as engineer we have to face. No, we have limited resources, and we have to give the best solution that we can with the limited resources we have. And so this is the most limiting aspect, let's say.
Mhm. So this entire concept of cost versus performance as such, the trade-off between the two. So in your experience as such, how exactly do companies and basically professionals in field of robotics determine the value of the end product and the various sensors and other instruments that basically come into it?
Well, everything depends of the let's say use case that you have with your robot. Because, for example, if your use case is just to move something from one place to another, and you are doing this in a factory that is a very standard environment, let's say, then you don't need very or super advanced sensors, because the world around you most probably is not going to change anytime soon. And so then you can just use a cheaper sensor, or then you can use just one sensor that is enabling you the localization and the obstacle avoidance, like, for example, a laser scanner, no? And instead, if you are using a completely different use case, that is, I don't know, a robot that has to take something from an sorry, let's if, for example, uh, you have a completely different use case of a robot that has to work in an outdoor environment, let's say, then you need completely different sensors. And also you need, because you have a completely different use case. So the real focus of robotics is the use case, because there is no robot, and there is no possibility actually to create a general purpose robot that you can use for all the purposes that you wish to. But there will be, and there are several different robots that just focus on one target, on one use case.
Mhm. Yeah. Okay. So now, this entire field, whether it's with respect to machine perception or with respect to, localization. So, I mean, getting into it is really fascinating, but like, what was your initial, you mentioned about how you started off with, internships in data science and then slowly moved on to, projects related to automation. But what is your initial, attraction towards this entire arena and field, and how did you get started with respect to that?
Yes. Well, normally in the, let's say, high school, I was just an average student, with interest in mathematics and physics in general, but I was just an average student, and to be honest, I didn't like that much to to go to school.
Mhm.
And well, because most probably was not getting the sense of it. I mean, especially with mathematics and physics, very often I was not getting the sense of calculating, for example, let's say an integral or a derivative. It was just for the pure pleasure of the calculation, it looked to me. And it was only when I started the university, I studied in Bari, in Italy. And only when I started the university, I saw the real application of the physics law, of the mathematics. And so it was something like, okay, so this is not just theory. I mean, we are making some, I don't know, we are creating some sensors that are using this physical process. Or we are, I don't know, we are making a plane flight thanks to the calculation of the integrals, for example. And so this was like the moment in which I felt in love, let's say, in general, with the mathematics and physics. And so then it came the robotics. The robotics came later, to be honest. The robotics came when I started with the Arduino. So when I firstly get in touch with the Arduino, and I saw how easily it is to apply all that knowledge, all the theoretical knowledge that you have in a simple board that was 10 euro. And so it was like, oh, wow, this is so easy. I mean, I just have to write one line of code to move a servo motor. And that was the moment in which I started with robots.
Okay. Yeah, Arduino is probably the way in which even I started off with robotics. Like the entire concept of, having such open source technology hardware, because open source software is one idea, but having open source hardware is,
Yeah.
it's truly revolutionary. So what were your projects which you did with Arduino boards and, basic electronics as such?
Well, yeah, I started with a lot of projects actually, and I think you can see one of them behind me. That is a small robotic arm that I created.
Okay.
And well, basically, I started, I think, like 90% of Arduino passionate with a device that was irrigating my plants, and so I think that everybody passed through it. And and then I started with building my very first prototype of a robot that was controlled with a simple joystick, a PlayStation joystick. And so that was my very first robotic project. I was not even aware of ROS. I was not even aware of a lot of software that has already been developed, as you said, from the open source software community. And so it was just my very first way of entering this huge world. And well, from that point on, I moved and I started learning ROS. I started learning ROS on my own. And from then on, I saw that it was, first of all, very difficult to learn. It has a very difficult, let's say, way of learning it, because it fuses together concept about software. So you need to be a good software engineer to understand all the concepts. Then you have to be a good robotics engineer in order to understand why something is developed in such a way. And then also, if it's good to have a mechanic and an electronic background, just to understand how the things are communicating with them and to understand the limit of them. So this is really the difficult part of learning in general ROS and robotics. And then you realize that actually when you are more skilled, and then when you are just you get used to it, you realize that ROS is not more than let's say something that enables you, something that helps you with all this stuff, with all these different concepts, because you are not able alone develop from scratch, so from zero, as I was trying to do, actually, you will not be able to build a fully functional robot. And so you need to integrate a software, an open source software that comes from some university, another software that comes from another company, and another software that comes from another company that is maintained. And so that is another person out there that is far more skilled than you, that is working to improve that software and that you can use freely. And so Ross then just puts together all this stuff. And so when you understand this, then it's very easy to you know to learn it and to use it for your projects.
Mhm. Yeah. So, yeah, I mean, it's very interesting that you actually mentioned that, because just last week, because our quarter is going to end for this, this academic section. So we had our final project, which was in the field of planning and decision making. So in that, we were using the gym environment as such to simulate everything. But most of the code which we used for, the path planning and getting that entire, trajectories and everything was mostly gotten from some open source repository and then changed for our requirements as such. So that the existence of that framework, the ability to take work from what others have built and then build upon that is just it truly just makes the job so much easier than it ever was before.
Yeah, I agree. I completely agree. And as I said, you don't need to be. I mean, there are very special sector and very specific sector when we talk about robotics. That is, for example, as you mentioned, planning. Planning is a complete subject, and you are not, and probably in the future you can be the more skilled person or the most knowledgeable person in that specific field. And there are people out there that are very, very, good in this field, and they are producing everyday papers. They are pushing the limits in that field, and they are producing open source software that you as a student can use for your project. And that I think is amazing, and you can just integrate it with one line probably. And that is the real power of ROS, and that is why it's so widely used, not only in research but also in lots of company as PAL Robotics, in which I'm working for. And it's still continuing being used from a lot of more companies, like NASA is going to use it for its Mars mission. And so this is really, really, really amazing. No, it's like when we first saw, the born of the first operating system for computers. They were basically enabling different applications to communicate between each other. They were enabling, I don't know, Google Chrome to communicate with your file system, or they were enabling this. So they were basically doing the same. So they were enabling different companies to build different software from you that you can use and that is integrated and that you can just download.
Yeah. And as you mentioned, PAL Robotics has also been using ROS. So from this entire concept of, tying up both automated vehicles and the entire idea of planning as such. So what kind of algorithms, what kind of, from the software side with respect to planning and decisions, probably for the slightly more, experienced members of the audience with respect to this form of technology, what kinds do you experiment with and apply PAL Robotics?
Well, this is nice because actually we do a lot of experiments because we are also a research and development company. And so we are working with a lot of research. We are doing a lot of research both in European projects and also for the open source community. And so there are lots of tests that we are doing, especially in the field of the fleet management, so having multiple robots coordinating between them. And this is one of the, I think, coolest project that I worked on so far, because it's really, I mean, if you love mobile robots and if you love self-driving robots, and you see, you know, 3, 4 robots that are coordinating between each other to accomplish a task, and so in order then one robot is moving away from the path of the other robot, that is really really amazing when you see that, and when you see all that logic that is working for you. And well, yes, I would say this one is one of the funniest one I've worked on.
Mhm. And when you speak about robots being used for, fleet management, is it like centralized where they're all controlled from one computer, or is it decentralized and they're able to, communicate between themselves and make decisions like that?
Well, also this, it really depends on the use case.
Mhm.
It really depends on the use case, because there are, I don't know, some places in which you don't have the possibility of having a reliable network, or some places in which you just want that there has to be a centralized way of coordinating the robot, and otherwise the robot should not move if
Mhm.
it is not connected to the centralized. So yes, I would say that this is hugely depends on the use case, and also often this is also dynamic. There can be areas in which you want the robot to be connected to the fleet and to take orders from a central computer, and areas in which you know that only a certain robot is going to be there because of its specific configuration. For example, I don't know, for the payload, you know that only a specific robot can take that task because of its payload, you know?
Mhm. Yeah, that makes a lot of sense. Understanding based on the use case as such. So, how do you think, all this technology with respect to fleet management and, using multiple robots, uh, do you think that that form of technology could actually help, maybe realize the entire concept of self-driving cars moving into the future? And how do you think that is going to look, probably in your vision, how far ahead, or, what would ideally be the picture when that is probably realized?
Yes. Um, well, in general, about self-driving robots, they are already, I mean, a huge reality.
Mhm.
So if we just focus on the, especially indoor self-driving robots, that is a factory, or that is your home, for example, with the AI robot is already a reality, and is already a very stable reality. I mean, this is just going to increase more and more, especially in the factories and in the houses, as I told you, because this is a very something that we already have tested for years so far, and so it's a very something that we can rely on. About the self-driving cars, so in general, about self-driving stuff that move around there in the world, that can be cars, that can be drones that will bring us our Amazon order, for example. um, I think that we are not that close, but we are going very fast to be at a good point. And I remember this Christmas, I was talking with a friend of mine who asked me if I would ever trust an autonomous car to to be my taxi, to take me to one place to another. And in order to answer him, I, um, I said to him a story that I was in Santorini, in Greece. And for those of you who don't know, Santorini is a very small island of 20 kilometers, I think. And basically, I was in the airport, and I took a taxi from the airport to my hotel. And I saw the taxi driver. I was seated in front, and I saw that the car at almost 1 million kilometers. And so it was like, wow, what what is what is happening here? And I asked to the taxi driver if all these 1 million kilometers were he did all these kilometers on his own, and if he did all these kilometers on a 20 kilometer island. I mean, it's super small. And he said yes. He said that he did all these kilometers there. And so I asked to my friend, would you trust this taxi driver to bring you to your hotel? And I mean, of course, he knows Santorini better than everyone. He did the island probably thousands of times. And we should see the self-driving cars the same way, because they will be they already have done billions of kilometers, both in simulations and in the reality. And also we have to think that this is not only one car that is doing 1 million kilometers, but for example, let's take the Tesla example. They have, I don't know, let's say 10,000 cars in Europe. All of these cars are sharing the same algorithms, and all of these cars are using the kilometers that are doing the other cars to learn from them and to learn from their error. And so, for example, if a car in, I don't know, Netherlands, where you are, learns that, for example, when it sees a balls in the street, it means that most probably a child will come out. Then the same algorithm, the same logic will be learned from a car in Italy, for example, without having never experienced it. And so we should think about these self-driving cars as the taxi driver in Santorini that will be, I mean, better than any of us can be.
That is such a beautiful example to actually explain the entire concept of, how a group of automated vehicles could actually have so much experience that put together the amount of experience is it's I mean, I don't even think that most of us can even comprehend how much they can know from, even if the number of automated vehicles is extremely small but very well spread out. I'm sure that everyone who's listening will definitely remember that example and this entire story as such. So yeah, moving forward with respect to your role, as you mentioned, at PAL Robotics, how does your daily, routine look like? How does your day go, and what kind of responsibilities and work can, all those listeners who intend to become robotics engineers at various companies, what can they expect as their general day-to-day work and routine?
Well, normally I used to go almost every day or as much as I can to the office. Although we have the possibility to remote working as almost all the companies, all the software companies right now. I normally prefer to be there, to be with my humans and robotics colleagues. And well, the responsibilities as such, basically, it's about translating into practical, let's say, prototypes, or translating the ideas and the requirements that are coming from the clients, the customers, or that are strategic, that are coming from the managers. And so it's really basically translating, doing this kind of translation between a use case that a customer can propose to you in a, then how do we build this in our robots, or how do we make our robots behave like this? And so it's just hopefully I work with a lot of smart minds, very I would say more I would say smarter than me, and thankfully it's very motivating to when you interface with other people that are smarter than you, and you feel like enhanced in your capacity, because you have so much to learn from, and they suggest and they think about something that you would never have thought. And so then you start a growing process. And so this is really the suggestion that I would like to give to any student and to any person that is entering the world of the work, and in general, not only in the robotics field, because this is, I think, something that is valid in all the fields, that find a good mentors, and surround yourself with people that knows more things than you do. And this is the best way to grow, actually.
Mhm. I see that makes sense. That ties together the entire picture of how exactly work goes. And how do you think that your experience after working for this long, how do you think it has been with respect to what you expected before you started working at a company like PAL Robotics?
Uh, well, it was quite, strange for the first time entering in the PAL Robotics offices in general, and see lots of robots moving around here and there. And so it was, at the first moment, it is like, oh, wow, this is a completely different, environment to the ones I'm used to. But then I realized that it was like to be, I used to, before working for PAL Robotics, I used to, and I still do, uh, build stuff on my own in my garage, so in my room. And basically being there, it was like being in my garage but working with many people. And so it was like a playground. And well, basically I then, after few weeks, I understood that it was like being in my own garage, but with more people, simply. And that's all. Yes.
Mhm. Yeah. So now I think that another really important aspect which I wanted to discuss with you is your role as an educator. So with respect to, your course on Udemy with respect to teaching people robotics. So first thing, like what was, that initial spark which you had, which made you believe that, this was necessary and that you had to create a course to address this particular demand which was maybe left unfulfilled at that point in time.
Yes. Initially, when I let's say started the course, I felt like there were not so many courses that were teaching you the practical side of robotics. Let's put it this way. And um, while I started, as we were talking previously, I realized that it was very difficult to learn everything about ROS, and because there were a lot of concepts that were, um merging between each others. And so I normally, my learning process is that when I do a course, when I follow for myself, when I for my personal growth, a course, or when I'm learning something, I try to create something mine that is based on the knowledge that I learned, and that is something that is not in the content of the course itself. So, for example, I don't know, if you are doing a C++ course, then at the end of the course, I would like to develop a stupid C++ game, 2D game that was using the concepts. And I did the same while I was learning ROS. So while I was learning ROS, instead of just learning the simple commands and the logic behind it, I wanted to use it in a real project. And so I created on my own robot. Actually, I just downloaded an open source robotics arm that is still the one behind my my chair, and I started writing the code with this one. And I mean, this is in my opinion, the best way of learning something. So if you just um, stop yourself and you just follow a course or follow a class at the university, then most probably you will remember that concept for 1 month or two, or if you are lucky and if you have a good memory that I don't have, you will remember for many more years, but still, you will not go into the details of what you are learning. And so if you build a real robot, or in general, if you apply those concepts to a real project, then you will see that there are so many things that you don't even know and that you don't even have thought about. And then you have to solve your problem. You are alone. Then you are alone. So there is no teacher, there is no assistant. You are alone. You are alone with your project and with your knowledge. And so that is the real moment in which you learn stuff. And so as a teacher on Udemy, I try to reproduce my learning process, that is this one, by creating something also on Udemy. And so on Udemy, with my courses that is now online and it is available both in Italian and in English, uh, we developed together a real robot. So you will have a nice toy to play with. And although we will create some small project together with this robot and I will use these small projects to teach Ross and in general to teach some robotics concepts, these are not the purpose of the course. The purpose is to provide you with a real toy, and also there is also a simulation that you can use on your PC to have the thing done faster, and in which you will develop your own ideas. So after the course, the idea is that you take your time, you have your toy. So it's nice to see on your desk this toy, and so you are, involved in the process.
Mhm. So, one of the questions which I've actually had for a very long time with respect to the creation of such courses as such is, how exactly does one come up with the entire, course structure, then, recording all the videos, getting all the material ready. So, how did you go about managing and, scheduling and planning this entire aspect of creation of the course, getting all the required material, and, finally assembling it and putting it onto them? How was that process like?
Well, yes, you are. I agree with you that this is a very challenging, let's say, organization, because very often, you have one idea when you start, and then during the process you change 10 times your ideas, and uh, as it should be. But the secret is just to get started. It's just this. You will start with your ideas. Okay, let's do this, and then during the process, it's an incremental process. So during the process, you will change your mind. Okay, I see that I started actually to make my course for the version melodic of Ross, and then in the meanwhile of creating, because it was the one that I learned, and in the meanwhile I switched to ROS Noetic, that is the last version of ROS 1. And so this is really an incremental process. And then you have to start, and then you realize that what you have done, it was not useless, but it was something that you can improve. And so you go back and improve it, and you continue this process. The thing is that very often a lot of people, not only I'm not only with courses, but in general with podcast as you are doing, or in general with any creation of something, very often they get lost in this process of in this iteration process. And so at the end, you have just to put yourself a limit, let's say, I'm not 100% sure, I'm not 100% confident that my course is going to work, but okay, let's publish it. Let's give some real feedback from the students. Let's get some real data. And because I can think that my course is not enough, but probably the students are loving it. Or it can be the opposite. For me, it's the best course in the world, but the students don't like my voice, or they don't like my approach, and so it's useless to continue to iterate this process. I'm not good at teaching. Probably the students will tell me this, and it's something that you have to iterate, because nobody nobody burns with this knowledge. And the best way is to just go out there and let the others give their opinion.
Yeah. And how was the feedback after you released your course in Italian and English? What is the feedback, and what were the various reviews that you got with regards to your course as such?
Well, I'm quite happy, to be honest, with the feedback that I'm having, because they are, as I said, they helped me a lot to improve the course material in first place. And also, they are motivating me to to continue to not only offering this course and to continue to improve this course, but also to create more courses that, now that I have a different knowledge, because I created this course for a mobile manipulator. But now that I have also more broad knowledge about, for example, autonomous mobile robot and self-driving, I'm also preparing a self-driving course. And so this is really motivating to see that students are really learning from you, and they are, when they, for example, also if they don't leave a review, but there are a lot of them that just write a message to me on LinkedIn or on Facebook or whatever, and just when they say, oh, your courses helped me a lot, and it was the only way I had to get started with ROS. And that is, something that is not only makes me proud, of course it does, but it also, gives you a meaning, and that you are helping other people.
Mhm. Okay. And how do you think, as you mentioned, you also have a course which is coming with respect to, automated vehicles, self-driving cars as such. And how do you think this entire, concept of online courses and online education in this massive open online classroom, or, purchasing like a course via Udemy, is going to change the technological landscape and, the trend with which robotics is going to spread across the world?
Yes, I don't think only robotics will be affected by this huge trend, but mostly all I would not even say only the technical, let's say, jobs. I would say that all the learning world is going to be, is already being affected by this enormous quantity of resources that are available online, both for free and pay to use, or just with normal purchasing of books and whatever. But for example, as I told you, I learned ROS, and I got started with, for example, a lot of topics in autonomous navigation, like for example SLAM, without having studied them at the university. So I have studied them on my own by using amazing YouTube channels, by using other Udemy courses, by using a lot of tools that are available out there. And very often they are, as I said, they are free or they are super cheap. On Udemy, very often you can find courses for 15 euros. And also very often there is now another platform on which my courses are also available and will be available, that is Skillshare, that basically works as Netflix. So you pay, I don't know, you pay 20 euros per month and you have access to all their courses. And so this is really amazing. And I got a job and I got started with robotics and ROS thanks to these resources that are available.
And now you yourself are creating the content and giving back to the community. And, that just brings this entire story to a full circle. Yeah. So, yeah, I mean, before we wrap up, I guess one question which most people would have who are tuning in is any general advice which you would like to give, probably people who are either in their undergraduate, graduate studies, or maybe just entered the workplace, uh, with regards to how exactly they can enter into this field, whether it's automation, with respect to anything in technology as such, what should be the ideal steps that they are taking to ensure that they have a good place? What advice would you like to give?
Yeah. Well, the advice that I would like to give them is to, first of all, being passionate about whatever topic you want to master and you want to be your job. And also, as we are talking about the online courses and in general online learning, the second one is, if you are passionate about something, you want to know more about something, and so never stop learning. So if you are interested, I don't know, in programming or web programming, there are tons of video and material that is out there. So if you are already also skilled, but you are passionate, you can always improve yourself. But this is not just about taking courses or reading books, because very often, due also to this enormous quantity of material that we have, we tend, and I did also this mistake, that we tend to rush from one course to another, or to, like in the university, from one lesson to another, and from one course you do the exam and then you start the other one. Your mind is there is no space for you to apply. Simply take your time and to apply the knowledge that you have. If, for example, you are doing a course about web development, take your course. After your course, create something yours. So it's really as simple as this. You have done your course about C++ programming. Take your time and develop your C++ algorithm. Have you done your course for an autonomous mobile robot or computer vision? Then take your time and, okay, I want to make a computer vision algorithm that is able to detect my hand or to count the number of fingers. That is the moment in which you are alone. There is no teacher that is guiding you. The teacher has provided you all the knowledge. Okay, this is all the teacher can provide you. Then take this knowledge and create something yours.
I think that's actually a very key insight, which I think a lot of our viewers are actually going to benefit strongly from. That is, after gaining any piece of knowledge from whatever the source may be, to actually just implement it practically in whatever capacity. Maybe if hardware is an issue, it could even be a simulation, but just to apply it and ensure that all those obstacles that come along the way are dealt with, so there is more experience from the entire journey rather than just accumulation of knowledge and equations as such. Yeah, and one final question. So, I mean, you have explored this entire field and you have a lot of experience with respect to whether it's online education, with respect to robotics, ROS, and even as in your role as a automation engineer. So, what would be some resources that you would probably recommend? I mean, I will obviously be putting the link to your course in the YouTube description. So, all those of you who are interested, you guys can check it out. But apart from that, do you have any other recommendations or anything which you would like to suggest which people should follow?
Yes, for sure. If you are interested in autonomous mobile robot and in general in mobile robotics, there is a good book that is Introduction to Autonomous Mobile Robots. And well, we will for sure attach the link to this book. And also another course that I loved, and but this is more specific to the to my colleagues that want to go into the autonomous navigation with a specific knowledge on SLAM. That is a very nice and free course on YouTube. That is a SLAM course by Cyril Staknis. I hope I said his name correctly, but anyway, we will attach the link to the resources. And he's a professor in Fraunhofer University. Can I check this one? Sorry.
Yeah, sure.
Fribourg University. Okay.
Mhm. So this is a course which is designed with respect to
Sorry.
focusing on-
Can I say again?
Yeah,
Fribourg.
sure.
Okay. He's a teacher at Fribourg University, and so he is very knowledgeable about this topic.
Hmm. So it's a course which is designed regarding SLAM, like focused on SLAM and its various types, or is it regarding just more higher level introduction to autonomous vehicles?
No, it's just focused on SLAM.
Okay.
So it's really taking all the the very deep concepts and mathematical aspects of the Islam.
Okay. I think that should be extremely interesting to all those of you who are genuinely, either already invested in or intend to invest in the idea of simultaneous localization and mapping. So you guys can definitely check that out. We will be putting the link for that in the description as well. And yeah, I guess that's about it, Antonio. This was a great conversation. Got to learn a lot, from even a work-life balance idea with respect to being an educator and multitasking. And I think one of the main takeaways from this entire conversation, which I'll definitely remember for a very long time, must be your story with respect to the taxi driver in Greece. It's a very visual and very
Yeah,
memorable story to remember.
yeah. When you
Uh,
want to convince someone to to accept the self-driving cars, you can use that story.
yes, definitely. And yes, I'm really looking forward to actually getting access to all your future courses as well. So we'll ensure that links and required material is attached as well. So
Yeah.
thank you so much. And if you have any closing thoughts or closing remarks, that'll be great.
Well, just to sum up, it's about the process that we said, no, about the iterative process of creating something. Well, when you create something and you launch it, the right moment in which to launch it is when you still feel ashamed of it. So if you are launching something and you are creating something that is a podcast, that is whatever, and you don't feel ashamed when you do that, probably it's too late. And so this is my closing point, and this is the moment when I launch my courses. So
Yeah, that that's just perfect. I mean, connects everything in the end. So yeah, thank you so much, Antonio, for agreeing to come on this podcast. And to all those of you who are listening, stay tuned for the next episode. And thank you for joining us today. See you.
Bye. Thank you.
Bye.